Hello everyone, I hope you're having a great day. Today we're going to be learning a new topic on exponential functions. So this is a brand new function that we are going to be learning. All of last semester we just focused on linear functions, y equals mx plus b. Today we're going to learn about a whole new type of function and what that looks like. So first, the rule: an exponential function is of the form y equals a times b to the x. So it's going to look like this. A lot of times we have parentheses around this as well, so you may see this as y equals a b to the x. Normally we put parentheses around it when we're working with this. And the a and b, they have specific meanings that are kind of special. The a, that is going to be the starting value. In other words, it is our y-intercept. And b is the amount by which y is multiplied, and this is called the constant ratio. So really similar to our linear functions, our y equals mx plus b, where b instead was our y-intercept, m was our slope, or how much y was being added each time. Now this time it's just a little bit different, because now instead of y being added each time, y is going to be multiplied each time. And we see that in this table here. And so here this table is representing the exponential function y equals 2 times 5 to the x. I see that my 2 is my y-intercept, my 0.02. So 2, that beginning number, my starting value, my y-intercept. And I see also that my 5 is what's being multiplied each time for my y. So to get from 2 to 10, I multiply by 5. To get from 10 to 50, I multiply by 5, and so on. And so we'll work with this a little bit later, but it's going to be pretty simple to make our equation from a table, just because it's kind of laid out for you right there. In exponential functions, I'm sure you've heard about it in the news quite a bit with COVID, but that's an example of an exponential function in real life, is the infection right there. So getting into the first type of example, identifying functions. For directions, we're going to determine whether each table represents a linear or an exponential function, and then explain. So again, our linear, we're going to be adding, subtracting y. Where our exponential, we're looking for multiplying or dividing. So looking at this first one, I see that my x's are just going up by 1. My y, I have 2, 4, 6, 8. So I can see I am adding 2 each time. And now since I'm adding each time, this is going to be linear. My explanation, add 2 each time to y. Also, if you were to just graph that, you would see that this would make a straight line. Exponential, or for my next table, I see I go 4 to 8 to 16 to 32. So I can first check and see if I'm adding each time. To get from 4 to 8, I add 4. 8 to 16, I'm adding 8, so it's not linear. But now I can see, okay, is there something I'm multiplying by each time? Well, to get from 4 to 8, I multiply by 2. 8 to 16, I multiply by 2. 16 to 32, I also multiply by 2. So that means that this one is exponential. And my reasoning here is I'm multiplying by 2 each time. Okay, that's it for this video. You can go ahead and move on to the next one.